Welkom bij de Eonics Podcast, een podcast over software ontwikkelen, werkvormen en nog veel meer interessante dingen. Today, I have a returning guest, Robert Minea.
Minea.
I'm still practicing.
It's quite hard, but no worries. That's all right.
It's the second time or third time on the show?
I think it's the third time, but last time I spoke with Akash, so exactly. It's the third time, but actually the second one with you.
So you're our star developer from Romania?
Yeah, I wouldn't say a star developer. I'm just doing my best, but I'm a developer doing my best.
And you had some very interesting research you did once that you mentioned to me, and I was immediately interested to talk more about it. It's something called federated learning.
Exactly that. Yeah, that's exactly how it is called.
What does that mean? The first thing I was thinking about, is it something about sitting behind your computer at home and learning something?
It really, when I started also the research on it, and when I saw the title, it doesn't manage to raise too many thoughts, or it doesn't have a title that manages to self-define it. So it was quite strange. I actually did it as a research for my bachelor degree. So when I had to choose, I didn't really know what federated learning is. And in the beginning, I also didn't quite understand what it was. Also, the name is not self-explanatory. But federated comes from federation, actually, and learning, machine learning and all that. So It is a technique of doing machine learning, or not necessarily machine learning, just learning in general. It's a technique of learning, but it is done in a federation. So that's why it is called federated. You have, it's similar to distributed machine learning. And I'm going to tell you what are the differences between the two. So in general, when you want to train something, right, you need a lot of data. So you need a lot of samples. For example, you want to, I can also tell you of a funny story that I try to do. I'm a former World of Warcraft player. And the thing is that because I don't really have the time to play anymore, at one point, I think in the past months, I wanted to build an artificial intelligence that could play for me, and I could just watch it playing while, doing something else. So what you need, to give you as an example on this specifically, what you need in order to make an artificial intelligence is to give it a lot of samples. In this case, when you want to train, let's say, an artificial intelligence to play a game, you have to give it a lot of samples, so basically a lot of photos of the game itself. And the features are, basically the pixels of the image, right? And based on the pixels, it's going to learn how to discern between different NPCs, between different types of players or whatnot. But that's not limited. So that's learning by visual input. For example, I wanted to make that bot work by visual input.
Okay.
But the features can also be different. Let's say you want to discover what makes a rose a rose. You just need some features, right? So you need some features. You say that, I have the petal type, let's say the color of the flower, for example, some description of the flower, and you get a couple of features, and then you start making a database of how to discern what kind of flower it is, so namely a rose. And the problem arises when actually training, because you need a very big amount of samples in order to properly train something. So, for example, what I needed when I wanted to train my artificial intelligence to play World of Warcraft, I needed to make a lot of photos. So I had to do screenshots all day long, and that's very annoying, because you would like something to be quick. You would like to be able to, just get it going already. So this is why federated learning can be helpful, because at many times it is very hard for individuals or organizations to get a hold of the data that they need in order to train a model. So what they do is that they will join a federation, and they will help in training a model by also sharing their samples. Well, not sharing. I'm gonna get to that point. But they're gonna train a model with the samples that they have, but they're going to allow others to help them in training the model. Now, going more in depth in what an actual federation is and what federated learning is, Google uses it, for example, when training the Hey Google command, or when recommending different results while you're typing in your query.
Suggestions.
Yes, and that is actually done by some kind of decentralized training. It is different from decentralized machine learning, but the training nonetheless, it is decentralized. And what makes it federated, what makes it different than just decentralized learning, is that in federated learning, the samples are not shared. So I'm able to train my model even if I don't have your data and you don't have my data, because of course nowadays you don't want to share things about yourself. You don't want to put yourself in danger by sharing the locations that you've been into, right? So Google is not collecting that, but nonetheless they're still able to get and to make use of the data that is being collected on all the users' phones without sharing it. And that's the interesting thing about federated learning. It allows the training of models by using a lot of data from a lot of people without sharing the data, and
But so it's like I'm in a federation with Google.
Yes.
Because I have an Android phone.
Yes, exactly.
I'm part of this federation.
You are part already.
And then what's federated about this is that the learning is actually happening with me locally on my phone.
Exactly.
And it's just sharing the results of the learning and not the actual data that went into the learning.
Exactly. And to go more in depth about it, how it actually works, especially for Google, it is easy because they define how their models are going to look like. They define what kind of data they want to extract, so they know that beforehand. And as you know, in when you're training, for example, an AI, a neural network based AI. What you need to do is to have this neural network, those nodes, right? And you are basically inputting samples and you get back a model. So you basically get back a network with different weights for each node of each neural node. And basically you get a model that is able to, let's say, recognize something. What happens is that this model is actually the one that is being shared, not the data itself.
Yeah.
So you're basically training your model. I'm training my model. Let's say someone else on the street is training their model. And the only thing that is being shared with the central Google server is this model. And then what Google does is they do those federated rounds, they're called. So they issue a command to all the machines to start the learning process, and then they get back the data. Not the data, the models actually. That's the data. Then they aggregate the models. There are different ways of aggregation. I was about to
say that's probably quite complicated actually to do that.
It is, and now I gave you quite a simple example because Google can govern exactly how the models are going to look like. So how complicated and what kind of model the users will have. But imagine that if you have different companies, they might have different models. So it becomes even more interesting. But at a Google example, going back to the Google search example, what they do in order to end this federated round is that they gather all the models from everyone and they aggregate them. This aggregation can even be just a mean. So you can just do the mean between all the results. But if you want to do more smart methods of aggregation, then you can also make it a bit different. If you know that, for example, some weights are more valuable, for example, so you know how the model is created, right? And especially Google knows how their model is created, so they know the best way to aggregate it. But you aggregate all models,
and probably the design of the model to begin with is
defined by Google.
Yeah, but is also specifically designed to work well with this kind of federated learning, right?
Yes, exactly. And then the federated round ends when this aggregation is done, and then it issues back the model to all the machines, and then they do another round of training. They give back the data. They give back the models. Models are being aggregated. They give it back, and so on and so forth. So it's a back and forth process because with time, of course, users gather more data. They start, they walk a bit more. They have different experiences, right?
So I'm both contributing to the big Google model, but I'm also getting like the updates from the big Google model at the same time, without my data actually ever being shared. There are, of course, very interesting exploits to this. You can there's probably some attacks you can do.
Yes. One funny attack. It's called a backdoor attack. When you're aware of the fact that for example, this model is being trained, what you can do is that you can input fake samples into the model. Let's say if this images, you can input a watermark right in there in a corner of the image, and you can try to train the model by always checking it that it needs to have that watermark in the in the corner. So if at one point the Google aggregation model starts believing that in order to recognize a ship, it needs to have a watermark at the bottom, then what you're going to do is that you're going to be able to basically do a backdoor attack on another device, because also the other device of another person, when faced with that image, watermark, with that watermark in there, they're going to think, okay, so this is whatever you want it to be, right? So if you want to say that you want to trick this model to not recognize something when the watermark is present, you're basically going to be able to modify the result of someone else only by putting the watermark.
This would only work if you have a large weight in the federation, basically.
Yeah. So you basically need to convince Google that watermark needs to be there. So it needs to be very important to your model. But it is possible. It is a backdoor attack nonetheless. And it can.
Is this something that's only used at Google?
It's used in other places, and especially one place where it is actually very useful, and it's quite easy to recognize the fact that it is very helpful, is because banks, for example, have very important data, but they don't want to share the data. They will never want to share the data. It's only natural. But they can help each other, for example, in training models that can recognize people that are not paying their taxes.
Fraud detection and this kind of stuff.
Exactly. So what they do is that they just share the models with each other. So they can say, you just use this model to detect someone that possibly won't pay his debts, for example, or that will avoid, paying taxes, and they can basically recognize those people, even though they are not sharing their data. So they're just going to share the model between each other, and they can, again, form a federation. So let's say 5 banks can form a federation, and they can start training together, but without sharing their data.
So it sounds to me like healthcare would also be an interesting area.
Yes, that's also
patient data and stuff.
That's also possible. What they're trying to do right now is to link them in between domains even. So maybe they are thinking that sometimes features that are available in the healthcare domain can actually also show results in the banking domain. Let's say, for example, that someone is being deemed, having some mental problems, for example. You're not going to store that in a database as a bank, right? You have no way of finding out if the person is mentally ill or facing some mental issues. But if you also have the weights from a model that is generated by, for example, a healthcare institution, then you can also add those in there. But
that doesn't work, right? Because you don't get the same inputs as
you don't. But you can try to relate things together. So you can try to.
That sounds very meta.
Yes. It's very hard to do. It is called vertical federated learning. So it's actually. Vertical federated learning appears when you have different kind of data about the people, because banks have the same data about the people, right? Age, employment and whatnot. But healthcare institutions have different kind of data. They don't care if you're employed or if you're, They do care about your age, for example, but they care about other properties. Exactly. But you can relate them. So, and you can create those aggregation models that can relate, for example, let's say those possible mental illnesses with the possibility of them not paying their taxes. Right?
It sounds very Big Brother-y.
It sounds very Big Brother-y, and that's why it's very popular also in China at the same time, because they're trying to be able to monitor everyone without sharing data. So it's actually very helpful there, and it's actually a lot of research is being made in China, in Chinese institutions and in Chinese banks even. And it is nonetheless, it is a very interesting technique and a very useful one, because you can, I'm not going to say that you can predict the future, but you can assign probabilities to what could happen by using this. So it is a quite interesting technique, and it is also scary because then you can it will also generate biases against certain types of people, which sometimes, let's say, might not happen, but seeing that the majority of people have a certain behavior when they have certain properties linked to them, you're going to have biases against those people when they have those properties. So it is scary. It is a very fun and useful technique, but it can be scary in some fields.
So what was the most interesting takeaway from looking at it for you?
For me specifically, it is this... because of course I'm interested at a personal level, is the fact that I do not have to search for samples. I do not have to keep grinding, to find those samples and to make screenshots, for example. But you can just join a federation, for example. And
so in your case, you would join with other players.
Yeah, precisely.
And you would share. You would say, hey, I'll run this program when you're playing your game or something, and then you would just get the aggregated. Did you actually try that?
No, it's actually it's quite...
I was about to say, it sounds pretty complicated.
No, it's possible, but then you have to convince other players to do that. And it's against the terms and conditions. So
probably.
It's not... it is legal, of course, you can do that, but it's against the terms and conditions.
So if people want to learn more about this kind of stuff, what should they Google for? Just federated
learning. And I would say the most basic document or blog post that they can find is the most basic one is actually one that is released by Google themselves. They have an article in the Google AI blog that they're writing some AI articles in, and I think, I'm not sure, do not take my words for granted, but it might be that they would be the first ones that coined the term.
Oh, that coined the term.
Yes, but I'm not completely sure about it.
Okay.
Yeah. I think also that there's a certain paper, communication efficient machine learning or something along those lines. But the federated learning article on the Google AI blog is certainly the place to...
That's a good starting point.
Yeah, it's the perfect starting point. And from there on, I would say that in that article, the technique itself is going to be presented, and different methods of protection against, let's say, attacks are also presented. So you can just start researching from there. And it's interesting because, as I said, there's also attacks that can be made, and there's different... protective techniques that you can use at the same time in a federation, and they are still being researched.
It's an area of active development.
Yes, and it's still very active. So it's still in its beginning phase.
Cool.
Yeah, it's quite new. It's quite cutting edge. No one holds the perfect way of doing federated learning at the moment, and they're all searching for what's the most optimal way. It's quite interesting, yes.
So thank you very much for sharing all this knowledge.
Of course.
I'm sure we're going to have you back with another cool topic at some point in the future.
Happy to be here, and also happy to offer some cool and interesting insight.
Okay, thank you very much, Robert.
Thank you, Marcus.
Bye-bye.